The TEAS 7 Math Tutoring Replay will start in just a few seconds. Get access to live group tutoring on math, science, English, and reading when you get the TEAS 7 online course. Enjoy the replay.
Hello, everybody. Happy Thursday. My name is John. I'm the founder of Smart Edition, along with my wife, Nurse Melissa. And today is the first tutoring session that we are offering live in the course. So we're excited to have everybody here today with us. We'll be going over math. We've got Ashley over here, and I'll be moderating this session. Ashley will be going through, she's going to go over kind of some different math topics, different concepts, and then we're going to do a bunch of practice questions. So we'll do all that live here. So I'll go ahead and pass it over to Ashley to introduce herself, let us know what we're going to go over today, and then we'll get right into it.
All right. Thank you. Hi, everybody. I'm Ashley. In a moment, I'm going to start sharing my screen so you can see a little slideshow I've made to go through a bunch of these practice problems. And there will be a few opportunities for you to take screenshots or grab your camera on your phone and take some pictures of some really important information that you'll need to know. So have that handy. I'm Ashley. I've been a math teacher for over 10 years. I've taught in the classroom, privately tutored students of really all ages, and I just really love math. So I hope that through our session today, you can find some ease in the math that we are doing for the entrance exam. So I have a few things we're going to cover today. These are basically 3 questions here that hopefully we will answer. So what kind of math can I expect to find on my entrance exam? We'll talk about that. I'll give you some different examples, and we'll do a bunch of practice problems. We're also going to talk about what formulas and or conversions you'll need to know and have memorized. So again, another opportunity for you to take some pictures and have these resources available to you even after the session. And then what will the problems look like? Well, that's what we're going to spend a good chunk of this hour doing. Okay, so we're going to be on for about an hour going through as many of these practice problems as we can get through. So here's a great slide for you to take a picture or a screenshot of. These are the type of math concepts you can expect to find on your entrance exam. So we're going to do some examples of all of these. You're going to need to know operations with fractions, so we'll need to know how to add, subtract, multiply, divide. You will definitely see word problems, so it's not just enough to know how to do the operation. We'll also need to be able to apply it to lots of different types of problems. We're going to do conversion problems, which is something that we are going to spend a good amount of time on today. I want you to see the conversions that you need to know, have some strategies to memorize them, and then also just see what types of problems will come up. Some will be pretty basic, where you just have to do a simple conversion. Some will be word problems that are specific to your field. Okay, we will also talk about ratios and proportions, percentages. We'll solve some equations, and then we'll talk about exponents and some circle geometry problems. Okay, so I'll give you just another second in case you did not get a chance to grab this with your screenshot or take a photo. And then we are going to talk about some of those formulas and conversions you need to know. So again, as I'm going through this, please give some feedback in the Q&A if you have questions about a concept that I'm talking about specifically, and then feel free to chat amongst yourselves in the chat feature so that we can all feel engaged. Okay, so where we're going to start here is some formulas. The slide is a little bit too big to get the whole thing in. Let's see if I can go out a little bit. There you go. So you should be able to just screenshot this whole page here so that you have this as a resource to look at. So give you a moment again, take a screenshot or a photo, and then I'll just talk about what each of these formulas mean so that when we go and apply them later, you have a little bit better of an idea. So circles, we need to know our circumference formula. That's what C stands for. So circumference is going to be pi times diameter. So sometimes we have to use pi and just leave it. It's just representing a number, that 3.14159 number that goes on and on forever, right? So sometimes we just use the symbol, or sometimes you might round to 3.14, but your problem will tell you how to do that. And then Because we can use a 4-function calculator, that allows us to do the math a little bit easier. So again, another thing you might want to have handy today is that calculator so that you can do some of these examples with me. So we've got circumference here. And then the next one here is area. So area is going to equal pi times the radius squared. So one way, it's just like kind of a silly mnemonic that I use to remember these formulas, is cherry pie delicious. Okay, circumference, cherry pie delicious. Apple pies are 2. Okay, so just a silly little mnemonic, cherry pie delicious, apple pies are 2, can help you remember those formulas for circles. And then I also just added here that the diameter equals 2 times the radius. When you look at a picture of a circle, okay, the diameter goes through the center from one end to the other, whereas the radius just goes from the center outward. So if you need to know the diameter, you can multiply the radius by 2. And conversely, you can also find the radius by just cutting the diameter in half. So just a little something you can add there if you'd like. Talking a little bit more about geometry, we've got some area formulas here. So triangle, area equals 1/2 base times height. Rectangle, area equals base times height. And then for a square, which is technically a rectangle, so this formula would still work. A special formula is just that the area is equal to the side squared, because all of the sides of a square are the same. And a little bit more geometry. Notice how a lot of these formulas are geometry that we need to know. We've got our volume formulas over here on this side. So cylinder, cone, okay, so cylinder, volume equals pi times the radius squared times the height. Cone is 1/3 times pi times the radius squared times the height. And then if we have a prism, which is basically like, think about a box, okay? You would just do a rectangular prism, length times width times height, or any prism, maybe say you have the base as a triangle instead of a rectangle, you would just do the area of the base. So let me just make a little note of this, that capital B means area of the base, and then you multiply that by the height. And then lastly, for pyramid, you're just gonna do 1/3 times the area of the base times the height. Okay, so a lot of information, but I wanna make sure you know what all of these letters stand for. And the last formulas I have here for you are just our temperature conversions. Definitely need to know these, okay? If you know one, then you can actually find both. You just have to know where to plug in. Do I plug in my Celsius temperature or my Fahrenheit temperature? But it can be helpful to have both of these memorized to save you a little bit of algebra when you're trying to solve for whichever temperature you're trying to find. Okay, so we will see some of these examples later on. I also have some conversions for you to have memorized. Again, you really want to have these ready to go. So when you see a conversion problem, you are just able to plug it in, use your calculator, and not have to think too much about the specific math and allow yourself to really think about the word problem and what it's asking. So have a quick little picture or screenshot of the volume and weight conversions, and then I will arrow down so you can see the distance. So shortly, I will also show you a little trick to finding some of these metric conversions. So metric units are when we're talking about like centimeters or millimeters or kilometers, like all of those units, we actually can find some cool ways to convert without memorizing all of those conversions. But some of them will be on here as a little bit of a repetition as well. Okay, and then I have one more slide for you, which will have some repeats, but it is a little more content specific for your nursing exam. These are the mass units or conversions that you really want to have memorized. Okay, so micrograms I don't believe was on the last slide, but that is an important one. And then you have milligrams to grams and grams to kilograms, and then also pounds to kilograms. So those are conversions that you will want to know for mass. And then we also have some for volume. Okay, so please feel free again to use that Q&A feature if you missed any of this. Okay, I just want to make sure that you guys have these resources as we go through some of these examples. So I mentioned just now when I was on that slide that there is kind of a cool trick that I want to show you if you are converting within the metric system. So this is a mnemonic, and a mnemonic is just a phrase, and oftentimes the sillier the better. It helps us remember it. So it's kind of a silly phrase to help us remember how to convert within the metric system in a little more quick and efficient of a way. So the mnemonic is King Henry died while drinking chocolate milk. Hence this silly little picture I have here for you. Okay, so King Henry died while drinking chocolate milk. Well, what does that have to do with the metric system? Each of these letters here of our mnemonic is a unit or a prefix of our metric system units. So kilo, hecto, this is deca. The W I use just to stand for a whole unit. If I'm talking about grams or liters or meters, that's where that would go. And then I have deci, centi, and milli. So these are all our prefixes that go before our units and allow us to figure out how large of a unit we're talking about. So let me show you how we can use this to convert pretty quickly. So I have a bunch of examples here for you. If this is something that is not really jiving with you and you're like, I already know how to convert, I have them memorized, I want to just try it on my own, feel free to go ahead and pop some answers in the chat. If you see my slide and you want to go ahead and just go for it, that's totally fine. But for those of you that feel like I'm a little bit confused when I have to do metric conversions or I struggle and it takes me a while, this may be helpful. So I'll do the first couple examples a little bit slower, and then I'll show you how quickly this can really happen. So for my first example, I'm going to convert 3,200 milliliters to liters. So my mnemonic up here, a great strategy when you're taking a test is to, if this is something that helps you, write this mnemonic down, write those letters down, have it on your sheet ready to go, because then I can reuse it over and over again. So I need to go from milliliters to liters. So I'm going from my M, and then I'm going to end at my whole unit. So this tells me to go 1, 2, 3 times to the left. So when I say go 3 times to the left, I'm talking about the decimal point. So the decimal point in a whole number is always just hidden right at the end. So if I'm going to swoop this 1, 2, 3 times to the left, it's going to land right here. So I got my little arrow there. So I can rewrite this number as 3.2. And notice how I'm leaving off those trailing zeros. I want to leave those off so I avoid confusion. And 3,200 milliliters would equal 3.2 liters. Okay, so let's try another one. If I have 0.67 or 67 hundredths of a liter, I want to convert to centiliters. So I'm going to start here, swoop 1, 2 times to the right this time. So 1, 2 to the right. Now my new number is 67. That decimal would be hidden at the end there, right? I don't necessarily have to write that. So that would be 67 centiliters. Okay, so let's see how quickly this allows us to do a couple of these other conversions that we may not know right away. So I have to go from decigrams to grams. So I'm just going to swoop once to the left. Swoop once to the left, and my answer is 0.489 grams. Notice how I added that 0 to the front of the decimal point. This here makes it clear that that decimal is visible, right? Decimal is just a dot. It can get lost at times. We want to make sure that we have that 0 for clarity. Now let's try to go from grams to milligrams. Okay, so grams is a whole unit. 1, 2, 3 times to the right. Let's swoop. 1, 2, 3 times to the right. Notice I have a couple empty spaces. I just fill those with zeros, and I get 5,300 milligrams. Okay, how about from centimeters to kilometers? I'm going to swoop 1, 2, 3, 4, 5 times to the left. So let's see what that looks like. 1, 2, 3, 4, 5. I should have given myself a little more space, but let me just make sure I have the right amount of zeros here. So it should be 1, 2, 3, 4 zeros after the decimal, and then the 2, 4. Okay, so I'll just give you a moment to try the last one on your own, either using this strategy, or if you already know the conversion to go from meters to millimeters, go ahead and give it a shot. 72 meters would be how many millimeters?
Ashley, there's a few questions, or at least one question in the Q&A. Wanted to make sure that we go over a word problem. I'm pretty sure you have that queued up.
Yep.
Just ensure the audience, we're definitely going to do a couple of word problems.
Yeah, we've got a few word problems in here for sure, and I know I have at least one specific to conversions, so we will
Okay.
definitely do one of those.
Okay, and another Q&A. This is one probably just good to go over. She's asking, what is whole numbers? So just a baseline definition of whole numbers.
Cool. So a whole number is essentially a number that doesn't have a decimal or a fraction at the end of it. So you can think about it as numbers that we count with, right? 1, 2, 3, 4, 5, 6, 7 goes on until infinity, right? You can go as high as you want for whole numbers, but we're not going to have anything after the decimal place, and we're not going to have any fraction attached to it. So when you think of a whole number, that is what we're talking about. So I hope that makes it a little more clear.
Thank you.
Cool. And then just for this final example, if you used this strategy, you would have swooped 3 times to the right. 1, 2, 3. If you know your conversion, then you would just have multiplied by 1,000, which we will definitely do some examples where we're just using our straight up conversions as well. But it would be 72,000 millimeters. Okay, so again, for some of you, this may be a thing that you take it and you want to apply it and you want to use it. And for some of you, you may leave it. You may say, this isn't really for me. I have my own strategies, and that's great. But now hopefully everybody has a strategy they can use when we get to our conversion problems. So we're going to jump into a mixed review of the content that you will see. We'll go through 1 or 2 examples of each of the different topics we mentioned in the first slide, starting with operations with fractions. So I've got a couple examples here. The first one we need to add. So let me I think I zoomed out before. Let me zoom in a little bit more so that you can see 3/8 plus 5/6 is the problem we need to solve. So when we are adding or subtracting, okay, fractions we add or subtract, we need to have what we call a common denominator, okay? So the first thing here is to realize we do not have a common denominator, and I know that because the bottom of my fractions, both of those numbers are different. So the denominator has to be the same in order to add my fractions. So 2 strategies you can use to find a common denominator. You can just multiply your denominators. So I could just do 8 times 6, and if your multiplication tables are a little rusty, that's why you have a 4-function calculator. Go ahead and plug it in your calculator, and you would get 48. So we could use 48 as our denominator, like rewrite these as something over 48 plus something over 48. Okay, we want to get those equivalent fractions so then I can add them together. So I'll show you how to do this, and then really quickly I'll show you another strategy that would be a little bit quicker for this example, but for this way that I'm showing you, it works every time. You can always just multiply those denominators to get your common denominator. So we're finding equivalent fractions. I went from 8 to 48 by multiplying by 6. So when I do it on the bottom, I also have to do it on the top. So 3 times 6 would give me 18. Now if I'm doing 6 times 8 to get 48, I have to do 5 times 8, which would be 40. And then I can add these two together because I have a common denominator and get 58 over 48. Okay, 58 over 48. Now, all of my answers are either regular fractions, okay, where the top is less than the bottom, or they've been converted to mixed numbers, which means I pull out whatever whole unit or whole number I have and then simplify my fraction. So we have got to simplify this into a mixed number. So 48 goes into 58 one time. I can pull out one group of 48, and 58 minus 48 would tell me I have 10 left over. So this is my mixed number, but it's not simplified. Notice how 10 and 48 are both even. That means that we can divide each of those by 2 and get my final simplified version of 1 and 5/24. So the fourth answer here would be our solution. So there are a few steps to this. Find a common denominator, turn that improper fraction into a mixed number, and then have to simplify it. Something else that would have been helpful is rather than using 48 as my common denominator, I could have just looked for a multiple of 8 and 6 because there actually is one that is lower than 48. We call that our least common multiple, LCM. And 8 and 6 share a multiple of 24. So 24 could have been the denominator we chose because 8 times 3 is 24. So 3 times 3 would be 9. 6 times 4 is 24. So 5 times 4 would give me 20, right? So just converting those into equivalent fractions. And now when I add, I get 29 over 24. And similarly, I still have to turn it into a mixed number. So 24 goes into 29 once with 5 left over. That would have allowed me to jump straight to this solution without having to simplify. So both are great strategies, but sometimes if we can use that least common multiple, it saves us a little bit of work. Okay, so just remember, main thing I want you to know when we are talking about adding and subtracting fractions is that you need to have a common denominator. Okay, so this was also a good review of that mixed number to improper fraction and vice versa, as well as simplifying. So lots of different things going on here. For our next example, we're going to try division with fractions. And actually, this one is division of mixed numbers. So again, I'm trying to show you a few different topics within this content at the same time because this is likely what you will see. So how am I going to divide these mixed numbers? For me personally, what I like to do is I like to turn them into improper fractions. So all that means is I'm going to have a fraction with a numerator over a denominator. Just happens to be the numerator is bigger than the denominator. Sometimes you call that a top-heavy fraction, but that's fine because then we can actually divide it. So here's my strategy to go from mixed numbers to improper fractions. So I'm just going to write this a little bit bigger so you can see what I'm doing.
Yeah, I think that's helpful. I think that's helpful. Actually, some of the question stem part is a little small.
They're a little small.
So
okay,
rewriting
yes.
them is super helpful.
Okay, cool. Perfect. So what I want to do here is I want to take the denominator and multiply it by my whole number. So 12 times 1 is 12. Then I'm going to add the numerator back onto that 12 and get 17. This is the same thing as 17 over 12. Okay, so all I'm doing is converting that mixed number into an improper fraction. If I do the same thing for 1 and 1/2, 2 times 1 is 2, plus that 1 on top gives me 3. This is the same thing as 3 over 2. Okay, so now how do I deal with this division? So how I have always done it has been using, again, another little kind of silly mnemonic. That just is one of those ways that just helps me remember exactly what I'm doing. KCF. What that reminds me of is KFC, right? Fried chicken, KCF. That is just something that has always stuck in my mind of how do I divide fractions? Well, let's see what that stands for. The K stands for keep. So I'm going to keep 17 over 12 as it is. The C stands for change. I'm going to change my division to multiplication. And then my F stands for flip. I'm going to take this fraction and flip it. So 2/3. So KCF means keep, change, flip. Okay, so that is how we can multiply fractions. Okay, I'm taking division and turning it into multiplication because the strategy for multiplying fractions is pretty simple. Okay, from here, all I have to do is multiply across the top. 17 times 2, which is 34. And across the bottom, 12 times 3, which is 36. And then notice how that is not one of my answers. That is because I didn't simplify. 34 and 36 are both even. That's a really great thing to look for when we are doing our fractions, is if they're both even, that means I can divide both of them by 2, and that means that they can be simplified. So 34 divided by 2 is 17. 36 divided by 2 is 18. So my final answer would be 17/18. Cool. So as we go through some of these other topics, I'd love to have some engagement where you guys are dropping your answers in the chat if you're not already. So as we go to some other multiple choice or little short response questions, feel free to be putting those in the chat so you guys can interact with each other as we go as well. So I promised you some more conversions. These are ones that may not necessarily be only metric conversions. We may be converting within the English number system or from metric to the English number, the system. Like, we'll have to figure out what some of these units are. But if you took pictures or screenshots of those conversion tables, those will likely come in handy here if you don't have all of these memorized. So I'm going to actually give you a moment before I jump into this. And I just want to see how many of these you can do. I'll give you about 30 seconds and see a good little self-assessment for yourself. Which of these conversions do you already know? Okay, we need to go from inches to feet, millimeters to centimeters, gallons to pints, and then pounds to ounces. And then I also at the bottom here have a conversion for military time. So I'll give you about 30 seconds. Feel free to drop it in the chat so we can see if we're getting the same answer, and you can give a little self-assessment of which one of these you know and which one of these do you kind of need to spend a little more time on and memorize. So for this first one, when I'm going from inches to feet, I need to know the conversion that 12 inches equals 1 foot. Okay, so that's the key here to solving this problem. And what that means is that when I'm going from inches to feet, I'm essentially just having to divide by 12. So if I take 27 divided by 12, okay, this might be a great one to just plug into your calculator because it's not going to work out perfectly, but we will have a decimal as our answer. 27 divided by 12 gives me 2.25 or 2¼ feet. So inches to feet, we're just going to divide by 12. If we were going in the opposite direction, so this is from inches to feet, if I was going in the opposite direction, rather than divide, I'd have to multiply. So I like to use my conversion over here to help me remember, am I dividing or multiplying? Because 12 divided by 12 is 1, but in the opposite direction, 1 times 12 would have to get me back to 12. So sometimes we can get a little bit lost in our thoughts or mixed up in our head. Do I need to divide or multiply? And this is a strategy that can help keep that clear if that's something that feels like it can be a little tricky for you. For the next one, we're going to take 67 millimeters and turn it into centimeters. So if you know how many millimeters are in a centimeter, you're good to go, right? You can just figure out, do I need to divide or multiply? But I want to just, again, show you guys for this other strategy how quickly we can use our mnemonic. King Henry died while drinking chocolate milk, and just go from millimeters to centimeters, swoop once to the left, and that means this would be 6.7 centimeters. So if you had used the conversion, all you had to do was divide by 10. Okay. This next one, going from gallons to pints. If you know how many pints are in a gallon, you can do this in one step. Okay, this wasn't something that was on our conversion sheet. We have a couple other steps we could do to figure it out. But if you know that already, you can do it in one step. The sheets that I gave you are not like an exhaustive list of all of the conversions you'll need to know, but it actually did have enough information for you to figure it out. So I want to show you, if you only memorize the ones that we gave you in this presentation, to figure out how do I go from gallons to pints, what you would have to do is know a couple things. You'd have to know, well, there are 4 quarts in 1 gallon. And then there are 2 pints in every 1 quart. Okay, so I could go from gallons to quarts just by multiplying by 4. So 8 times 4 would give me 32. Well, that's in quarts. Now, if I want to go from quarts to pints, I'm going to have to multiply that by 2 to get my answer of 64. Okay, so using some of these that maybe you already knew or saw from our conversion table, you could convert using multiple different conversions from one, just to go from one unit to the other. Or maybe you already knew that there are 8 pints in a gallon and you could just multiply by 8. Cool. All right, and we have one more conversion here before we do a time conversion. I'm going to take 12.5 pounds and turn it into ounces. The key here is to know that 1 pound is equal to 16 ounces. So if I'm going from pounds to ounces, notice how it's getting larger. I'm multiplying by 16. So I'm just going to take 12.5 and plug in my calculator, multiplying that by 16. Okay, so 12.5 times 16 would give me 200 ounces. Cool, and just another example of a conversion that you may not see on a chart to memorize, but you do need to know is how do I go from our 12-hour clock time into military time, into that 24-hour time. So if I have 9:27 p.m., the key here is to notice that PM means afternoon, right? It's afternoon. In our time, we go up to 12, and then we start back over at 1. So the key here is to know that when I see PM, if we're after 12 p.m., starting at 1, 2, 3, we always have to add 12 back to it. So 9 plus 12 gives me my hour of 21, and then the minutes 27 just get plopped on there. I drop that colon. So in military time, that would just be 21:27. Cool. So we got some conversions, and I do have here one example of a word problem that you may see. A doctor writes a prescription for 0.5 liters of liquid medicine to a patient. How many milliliters will the medicine bottle be filled with? Okay, so if I have this given to me and I need to find how many milliliters, okay, essentially what I'm doing is converting from liters to milliliters. So the question is 0.5 liters equals how many milliliters? So if that strategy of using mnemonic has been helpful for you, go ahead and try it. If you know your conversion, again, go ahead and try it by multiplying or dividing to get your new unit of milliliters. And feel free to drop the answer in the chat. Let's see how we do with a question like this. So I'll just give you about 15 seconds or so. I think this is one of those questions that you either know it or you don't, and that's okay because I'll go over it. So for this here, I'm going to just show you the conversion to go from liters to milliliters. I just have to multiply by 1,000. So 1/2 times 1,000 would give me 500 milliliters. So if you put that as your answer, nice job, you got it. Cool. So we do have quite a few more topics I want to try to get through in the next 20 to 25 minutes. So I'm going to zip on to the next topic here. We're going to talk a little bit about ratios and proportions. Before we look at this example specifically, ratios and proportions are essentially something that we want to think about as fractions. So you'll notice when I'm doing this problem, I'm going to use fractions to help me solve it. There are other ways to do it, but when we're trying to solve some of these more complicated ratio and proportion problems, fractions can be really helpful. So ratios, just as a quick little note, can be written in a few ways. So say I have a ratio of A to B, okay? If I were to literally write that out, A to B, it would look like this. I could write that as A colon B, or I could write that as a fraction of A over B. It's very important to note that the order in which you write a ratio and where you put those numbers is very important. These are not the same. These are not the same as B to A or B over A, right? A over B and B over A are definitely not the same thing. If you think about a fraction, 2 over 3 versus 3 over 2. Changing the order of that changes your value. So one thing I just want to note here is that your order and where you put those numbers is very important. So let's zoom in here and try a little word problem using ratios and proportions. If a recipe calls for 3 parts flour to 2 parts sugar, how much sugar does a baker need if she uses 12 cups of flour? Okay, so pretty relevant if you like to bake, especially these days around the holidays. You may need to do a problem like this, and you might not think about it too much when you're in your kitchen, but I just want to break down how we could do this regardless of what the numbers were and what we're talking about, flour and sugar, or be anything else, right? So if I have 3 parts flour to 2 parts sugar, that's essentially a ratio of 3 to 2. I'm going to write that as a fraction. So I'm just going to write 3 and I'm going to write flour, okay, over 2 and I'm writing sugar. I'm just using those to remember what am I putting on the top and what am I putting on the bottom. Flour's on the top, sugar's on the bottom. So when we're doing a ratio or a proportion, it needs to maintain the same value. So if I'm using 12 cups of flour, this ratio will be equal to 12 cups of flour, right? Flour is on the top, to how many cups of sugar? I'm just going to label that X. Okay, this is what I'm trying to find. How much sugar do I need for 12 cups of flour? So 2 ways to solve this. Think about them as equivalent fractions. 3 to 2 equals 12 to what? Well, 3 times 4 is 12, and 2 times 4 would give me my answer of 8. Okay, so if you're pretty good at equivalent fractions or just see patterns in numbers, you might have seen that pretty quickly. But if you want another strategy to solve a question like this, we could cross multiply. So 3 times x and 2 times 12. So cross multiplication comes up a lot when we're talking about these proportion problems. And essentially we just go across the equal sign and do 3 times x equals 2 times 12. And now I just have a pretty easy algebraic equation to solve. Divide by 3 and I'll get x equals 8. So your answer either way would be 8 cups of flour. Okay, so this is a fairly basic question, but this strategy, and that's really what I want to hone in here, is strategies you can use. This strategy will work for any numbers, no matter how complicated they get. Okay, so let's try a percentage problem. What is 32 out of 160 as a percent? Nice, so we've got 4 multiple choice options here. I'm going to give you a moment just to see if you have a strategy that you could use to try to turn this into a percentage. And then I will offer one up for you in 15 seconds. So what I would do here is, for me, I'm a mathematical person, so I'm going to offer a way to do this a little bit more mathematically, and then we can talk about how we can just think about numbers as well, because that may not work for everybody. So if I'm going to do this 32 out of 160, that automatically makes me think of 32 over 160, 32 out of 160. So essentially all I have to do is simplify this fraction, which will give me a decimal, and then I can turn it into a percent really easily. So if I have a decimal, going to a percent is easy peasy. So when we have a fraction, that fraction bar essentially is just division. So this is the same thing as just doing 32 divided by 160. Go ahead and plug that in your calculator, and you will get 0.2. So 0.2 is my decimal version. Now I want to figure out, well, what is that as a percent? Well, percent means out of 100. Okay, percent, you might notice that CENT at the end, cent, 100 cents in a dollar, or 100 years in a century. What we have to do here is just multiply by 100 to get 20%. Okay, so really important skill for your entrance exams and some of the word problems you will see is being able to convert back and forth between fractions, decimals, and percentages. So this is one way that you could do a question like this. You also could use your multiple choice options to help you here and say, well, 32 out of 160, what does that seem pretty close to? So I know that like 30 out of 150, 30 times 5 would be 150. So it probably goes into, 32 probably goes into 160 about 5 times, just estimating and trying to think about these numbers. So what goes into 105 times? Well, that would be 20, and that would check out here. But that would also allow me right off the bat to get rid of 12, because that seems like it's quite low. And it's definitely not 50%, because that would have to be half of 160, which would be 80. So right off the bat, with just kind of thinking about what I know about numbers, I could get rid of 2 of these options as pretty unreasonable, and then just have to figure out if it's 20% or 22%. So that is another strategy as we're looking at multiple choice questions, to allow you to focus in on the answers that make sense and get rid of the ones that don't. All right, let's try some algebra, solving equations with one variable. I'm going to give you one that's a little bit more simple, and then we're going to do an example that's a bit more complicated. So we're going to solve for the unknown value, or for the x. So I'm going to write this a little bit bigger again because it's just a little bit small in the way it's written. X over -2 minus 3 equals 5. So I'm trying to solve for x. I have to get rid of anything else that's on the left side of this equal sign. So I have x divided by -2 and then minus 3. So notice how these are one fraction. These are attached here, but it would be really easy for me to get rid of this -3 just by adding. So that's what I'm going to do first. Using an inverse operation, the opposite of subtraction is addition, I'm going to add 3 to both sides. And I'm left with x divided by -2 equals 8. Now, again, using inverse operations to get that variable, that x by itself, x divided by -2, well, what's the inverse of division? That would be multiplication. So I basically just have to multiply by -2 to get that to cancel out. But if I do it on one side of the equation, I always have to do it on the other to maintain balance. That's essentially what an equation is. It's just something that we keep balanced. So I do it on one side, I have to do it on the other, and this would simplify to x equals negative 16. So that was just a little two-step equation to get you warmed up for one that looks a little more complex. So this is an equation that we are going to try to solve together. Kind of a lot going on here, so let's break it down. We have 2 times in parentheses, notice these parentheses, they're important, 4x plus 1 minus 5 equals 3, and then minus, and I have another set of parentheses over here, 4x minus 3. So before I start to move things over, trying to get the variables by itself, I want to simplify wherever I can. And in this case, that means trying to distribute or multiply out to drop those parentheses. So I'm going to distribute on the left side this 2. And then on the right side, I actually have to distribute this negative sign, which is the same thing as multiplying by a negative 1. So that's going to be my first step, is to distribute, and then I can start to simplify a little bit more. So 2 times 4x, 2 times 4 is 8, so that's 8x. 2 times a positive 1 would be a positive 2. The minus 5 stays along for the ride, equals 3. And then let's see what happens when we distribute this minus sign. Negative 1 times 4x is negative 4x. Negative 1 times negative 3. Notice I'm multiplying a negative times a negative, or distributing that negative side in there is going to force me to change that to a positive 3. Now that I've distributed, I can combine like terms. So I'm looking at the left side of my equation first. If I have variables I can put together or smush together on the left side, I will, but I only have constants. So I'm going to add these. The 8x can't combine with anything, but I can do plus 2 minus 5, which would give me a negative 3. And then on the right side, again, I can only combine my constants here. 3 plus 3 is 6. And then I have minus 4x. So sometimes we start solving these equations and we get stuck at this point because we're like, what do we do? We have a variable on both sides of the equation. Well, your goal is to get them on the same side, because then I can get it by itself. So same way as we were using inverse operations in the last example to move things over, I'm going to do that as well. So negative 4x, I want to move that over. So what I'm going to do is add the 4x to get it to cancel out. And I'm going to add it to the left side as well to maintain balance. So 8x plus 4x gives me 12x minus 3 equals 6. Now I have a pretty simple equation to solve at this point. I can add 3 to both sides and get 12x equals 9. And then lastly, I will divide each side by 12. And if you plug this in your calculator, you're going to get a decimal. But notice how all of my answers are either fractions or whole numbers. So what that means is I really just have to simplify my fraction. So I have 9 over 12. I'm just going to rewrite that up here. I got x equals 9 over 12. How do I simplify that? Well, what do 9 and 12, what factor do they share? They both can be divided by 3. So I'm going to divide by 3 to get 3 over 4 as my final answer. Okay, so we started out with a pretty complex equation. Once we distributed, combined like terms, and then moved the variables over to the same side, it got pretty simple. And then we just had to deal with a fraction. So this is the type of equation that you can expect to see and have to demonstrate your knowledge of solving on your exam.
That does look a little complex, Ashley, but you did a good job solving that. How are you looking on time? We've got about 10 minutes or so left. I don't know how many questions you have.
I think we're good. I'm just going to bounce through a few exponents, practice how we use that since we can't use our calculator for some of those. And then I've got 2 circle problems. So I think we'll be good to finish right up around 7.
All right, cool. Sounds good.
Cool. Awesome. And thank you guys so much for sticking around with me. I know I'm doing a lot of talking, but I hope that the explanations are clear and you're able to follow along and feel more comfortable with some of these topics. So, like I just said, we're going to do some exponent stuff, and then we're going to do a couple circle problems, and we're going to wrap it up. So let's just talk about exponents real quick. Essentially, an exponent is just some number as the base raised to the exponent, which just tells me I'm multiplying whatever that base number is times itself a certain number of times. So 5 squared just means 5 times 5. 5 times itself twice. So 5 times 5 would give me 25. Okay, so pretty straightforward. What happens when I have to do 2 to the third power? So 2 to the third power, or 2 cubed, means I have to take 2 and multiply it by itself 3 times. 2 times 2 times 2. Please, please, please do not make the mistake of just doing 2 times 3 and getting 6, because that's not our solution here. When we are using an exponent, we have to do 2 times 2 to get 4, and then multiply that number by 2 to get our solution of 8. So 2 to the third power would be 8. Sometimes we also have to deal with negatives. So notice, again, I'm really pointing out parentheses because this can change a math problem just by adding parentheses. So these parentheses are important. Let's try to do negative 3 to the third power. I'd have to do negative 3 times negative 3 times negative 3. So what do I do here? Well, if I do negative 3 times negative 3, I get a positive 9. And then I have positive 9 times negative 3. A positive times a negative is a negative. 9 times 3 gives me 27. So that would be my solution. This would be a different answer than if I just had negative 3 to the third without those parentheses. So definitely important for us to notice parentheses when we are solving problems and not overlook them. So another example of that, and when we might need to see these exponents in an application, is when we're asked to evaluate an expression like this one. So when we're asked to evaluate expressions like this, we're simplifying and trying to find the value of this expression, but we have to do it in a specific order. That is called order of operations, or that is also sometimes referred to as PEMDAS. You may have heard that. Maybe that reminds you of grade school learning PEMDAS. Please excuse my dear Aunt Sally is one thing that I'm sure plenty of us have heard in our lifetime. So what this stands for is the order of which we're doing operations, parentheses, then exponents, then we do multiplication and division. We just work from left to right. And then addition and subtraction, again, we just work from left to right. So I'm going to start simplifying and practice some of this stuff with exponents. So I'm doing my parentheses first. So I have to deal with this. So the first thing I have to do within those parentheses is the 4 squared. So 4 squared is 16. And then I'm going to subtract 10. 16 minus 10 would just be 6. So all of this stuff in the parentheses just simplifies to 6. So I'm going to write everything else as I saw it before. Okay, so 3 squared plus 5 times 6 minus 8. Now if I simplify, I'm done with my parentheses, I move on to my exponent. Now it's outside of those parentheses, so that's the next thing I can do. 3 squared is 3 times 3, which is 9, plus 5 times 6 minus 8. Parentheses, exponents are done. Let's see if we have any multiplication or division. Well, this represents multiplication. So 5 times 6 is 30. And I'm just working my way down. Sometimes this is called the pizza method. We're getting smaller and smaller, skinnier and skinnier until eventually we get our final answer. Now I'm going to do addition and subtraction, working left to right. The 9 plus 30 comes first. And finally, I get 39 minus 8 to give me an answer of 31. Okay, so one way that you may see exponents is within your order of operations types of questions when they ask you to evaluate an expression. Okay, and we've got one more question. I want to talk a little bit about circles, and then we'll do one example and we'll be good to go. So when we are talking about circles, we need to know some terminology. So this specific question, which is from one of our courses, just asks you to identify a diameter of the circle. So if I'm looking at this full circle, the diameter would be a line that goes through the center from one end to the other. So the only line that goes through the center, through that center of the circle, from one end to the other is here. So the diameter would either be written as BD, or you could write it as DB. The order doesn't particularly matter, okay? What if I asked you to find a radius? Well, there's actually quite a few here. Here's one radius, CO. Another radius could be OB or OD. All of those could be examples of radii of this circle. And then the one here that we didn't talk about, AE, this is really just called a chord. It just goes from one point of the circle to another without going through the center. So that's called a chord. So just a little bit of vocab that you want to know when we are talking about circles. So when we see a problem like this, we know what we're doing. So the circumference of a circle is 45 inches. Find the area of the circle in square inches. Round to the nearest tenth. Use 3.14 for pi. So I need to know those circle formulas in order to solve this problem. So we talked about them a little bit before. We need to know circumference is equal to pi times diameter, and area is equal to pi times the radius squared. So again, that silly little mnemonic that might be helpful. Cherry pie delicious, apple pies are too. Okay, so let's just plug in what we know to try to get our way over to finding the area. Circumference is equal to 45. So I'm plugging that in for C. They're telling me to use 3.14 for pi. And I need to find my diameter because that's the only thing in our circumference formula we don't have yet. So I'm just going to divide by 3.14. Again, we're just going to let our calculator do this for us. And I'm just going to round to a couple decimal places. I get about 14.33 as my diameter. So how does that help me find my area? Well, if you remember, diameter is just 2 times the radius. Or in other words, the radius is half of the diameter. So cut that in half. If I just take 14.33 divided by 2, this is about 7.165. Okay, you probably at this point could probably just write it as 7 and be okay. Okay, because if I look at my answers, none of them are really too close together. So rounding should be okay at this point. So I'm just going to say my radius is 7. So let's plug that in. 3.14 times 7 squared. Okay, so again, there's an example of when you might see an exponent. 7 squared is 49. So I have to simplify 3.14 times 49. And when I do that, I get about 154 as my answer. So remember that I rounded a little bit, right? My answer here was 7, which was less than what the actual radius would be. And I rounded here too because when we're using decimals, sometimes we get in our calculator a long decimal. So this is where once we get an answer, we need to now just choose the one that is the best fit for what we got. So the closest by far here is 162.8. So depending on how you round your answer, you may have a different strategy than me as you're working through different problems. You may get closer to 162.8 or a little bit farther away, but either way, just using that question of like, what's the most reasonable answer? We can get this as our answer, but still know that 162.8 is the solution. Okay, so that's the last one I have for you guys today.